Hello everyone, myself Maruti, welcoming you all to this math video session. Right, in this video, I'm going to take a topic from trigonometry and I'm going to prove something for you. It's an important sum, I bet on. So here the question is, we are supposed to prove that secant theta minus 1 by secant theta plus 1 equals cot theta minus cosecant theta whole square. I repeat the question. Secant theta minus 1 by secant theta plus 1 equals cot theta minus cosecant theta whole square. That's the goal what we are having. We are supposed to start here and we are supposed to reach here, right? Now, when we are looking at the question, we are supposed to see what kind of trig ratios are there in the question and where we are supposed to reach, and moreover what square identities, what multiplicative identity, what fundamental identities we are supposed to use, right, to reach from secant to the other trig what's given in the answer, whatever it might be. Moreover, if we observe it cool, there is no square in the question, whereas we are having square in the answer. That's the main trick, right? We can't get a square straight away. We are supposed to do add on some stuff, make it to get to the square. That's the logic what we are having. I'll get back to you. We are in the process of that. I will teach you how to get that. So now, if you start at the given question, right, we are supposed to start at the given concept. Right. So see here, secant theta minus 1 by secant theta plus 1 is the given question. My ultimate target is nothing but to get the whole square. So I started thinking, so what's the only concept what I like to do means, I like to take the question, right, I like to multiply with the conjugate of the denominator. We can call it as conjugate, or just to the opposite side. So we are having secant theta plus 1. I like to multiply and divide the entire given question with the secant theta minus 1. That is what, just let me show you that. Secant theta minus 1 whole divided by secant theta plus 1 is there. To that, I like to multiply and divide with secant theta minus 1 by secant theta minus 1. What did I do? Multiplying and dividing with secant theta minus 1. That's the logic what we have chosen here, right? Multiplying and dividing by, what's that? Secant theta minus 1. Why did we do that? What's the purpose at the back of that? Why? Because please remember, if you see the numerator here, it is in the form of secant theta minus 1 into secant theta minus 1. We know a into a equals a square. We know that. Therefore, I like to keep this entire stuff in a bracket, this in a bracket. Now, this entire stuff I like to call it as a, into this entire stuff, whatever is there in the bracket, I like to call it as a. Now it becomes a square. That is secant theta minus 1 whole square. Fine. Means whole square I have written. No issues. Now whole divided by, now if you check the denominator, wantedly I am writing like this. So it's nothing but secant theta plus 1. Fine. And secant theta minus 1. Cool. Right. Now I started thinking, yes, I got square in the numerator by using the formula a into a is equal to a square. Same into same is equal to same square. Fine. Now let us see at the bottom, right? We got the right. Our ultimate target is we need whole square. But we get square for the numerator itself. We need to get square in the denominator also. Now, if you check it out, is it not looking like in the formula a plus b into a minus b? Yes, it's looking like a plus b into a minus b, which is nothing but a square minus b square. Now, let me go for that. In the numerator, we are having secant theta minus 1 whole square, no issues. By the denominator, if you consider this as a and this as b and this as a and this as b, it is looking in the form of a plus b into a minus b, which equals a square minus b square. These are the two right? This is the formula what I am going to use now. So now I am writing it like a square minus b square. What is a here? It's nothing but secant theta. It's nothing but secant theta, and b is nothing but 1. So please good. So in the numerator I am using like same into same is nothing but a square, same square. Now in the denominator it is in the form of a plus b into a minus b, which is nothing but a square minus b square. Now I want to say you one thing. You are supposed to remember this one. Whenever we are not having square for any trigonometry and we like to get back in the square, we are supposed to use the formula a plus b into a minus b. Means if you are having a plus b, multiply with a minus b so that we get a square minus b square. Or if you are having a minus b with you, multiply with a plus b, then you will be getting a square minus b square. That's the logic. So from non-square to a square, use this formula. This formula is helpful for you. Now we are on the track. Now here we are having secant theta minus 1 whole square by, if you check it out, it's nothing but secant square theta minus 1. That's cool. Okay, now we are, but we need whole square here. But where we are, we need to reach the whole square. Now, my ultimate goal is the numerator, I like to write it as secant theta minus 1 whole square, no issues. Now, the denominator, is it secant square minus 1? I can write it as tan square theta. I am writing it as tan square theta. How did you get that? So, by using from square identity to, what's the square identity? We are having secant square theta minus tan square theta equals 1. Whereas secant square theta minus 1 is equal to tan square theta. Yeah. So secant square theta minus 1 can be written as tan square theta. Now, if you check it out, where we have reached till now, where we have reached till here, we are having in the numerator secant theta minus 1 whole square by tan square theta. So in a planned way, I am writing like this: secant theta minus 1 by tan theta whole square. So if you observe, we are having square here and also we are having square here. So what I have done, I made it as whole square. Why? Because what is needed? We need whole square there. Now I started working. Now the only one thing what is required is whole square. We got it. Now I am checking the other part. Do we have any denominator here? We don't have any. So we have reached a point, secant theta minus 1 by tan theta whole square. So the target is we have to reach from cot minus cosecant whole square. So logically I am going in a different manner now. So the secant what I am present is I am writing it as 1 by cos theta minus 1 whole divided by the tan present here. I like to write it as sin theta by cos theta, of course, whole square. Okay, so how did you get that and what is the purpose we are getting? So we know from so reciprocal identity 2, we know that it's nothing but cos theta into secant theta is equal to 1, and secant theta can be written as 1 by cos. So because of this reason, secant theta can be written as 1 by cos. That is the first point. And from quotient identity 1, we know tan theta is nothing but sin theta by cos theta. Because of that purpose, I have converted tan as sin by cos by using both these logics. Now, let us go for the next step. Now, of course, we are stuck with the same whole square. Fine. Right. General basic stuff. When we are having numerator and denominator in between plus or minus, we have to take LCM. Of course, this is the main denominator here. Now, I am taking LCM for the numerator stuff. The LCM what we are getting is cos theta. Why? Because if there is no 1, it's nothing but 1. Cos and 1, LCM is nothing but cos. Now, cos goes in cos, same goes in same one time. 1 into 1 is nothing but 1 minus. Now, 1 goes in cos. Whenever we are checking 1, whatever is present there, we have to take that cos type. Cos into 1, it's nothing but cos theta. It's cool. Okay. Now what's there in the denominator? Denominator we are having sin theta by cos theta. You should not forget that. Right. Now we are done with almost of the sum. Just let's a few more steps are left over. What's the denominator here? It's cos. Now what's the denominator here? It is also cos. Now straight away cancel the cos and also the cos. Right. Whatever is present inside, we are cancelling that. Now what is left over? Of course, whole square is already present. Now in the numerator what we are having 1 minus cos theta, whereas in the denominator we are having sin theta. Till here we are all set, right? Now let's see the answer there. So whole square, but here we are having two terms, whereas we are having only one term. The denominator what is present there, I like to split for both the terms. So here, which is nothing but I am writing this as 1 by sin theta, right, minus I am splitting to the second one, cos theta by sin theta. Just I have splitted the denominator for both of them. Now if you check it out, now how it is looking like 1 by sin theta. We are having few square identities or multiplicative identity. From multiplicative identity 1, we know sin theta into cosecant theta is equal to 1. Right. Now cosecant theta is equal to 1 by sin theta. Means wherever we come across 1 by sin theta, in the place of that we can write cosecant theta. Can't we see that 1 by sin theta? So what's my plan? Let's write it as cosecant theta, that's fine, minus, and from quotient identity 1, right, quotient identity 2. What's the quotient identity? Wherever you come across cos theta by sin theta, we can write it as cot theta. That's the rule what we are having. In the same way, cos theta by so and so, we are getting as cot theta whole square. Yes, we are done. Check it out once again. Cosecant theta minus cot theta whole square. We are, come on, that is the tricky part. We are having cot theta minus cosecant, whereas we got it as cosecant theta minus 1. Now we are supposed to something messed up. Right, we need to swipe that. So what is the easiest logic to do that one? Means what I am doing, I am sending this one here and this one branch, just I am interchanging places. Now it's minus cot theta plus cosecant theta whole square, no issues till here, fine, but that is not what we want. So what I'm doing, I'm taking the minus common, right? You guys know what's the meaning of minus. Plus is nothing but minus into minus. So plus is nothing but minus into minus. The minus which is present here, the subtraction sign, what is there? I like to take it as common. So what I am doing, so whole square, I don't want to disturb that. So what I am taking, the minus present there, I am taking it as a common. So if you take it as common, right, it goes outside. What is there? Cot theta. Now plus is minus, meaning is minus into minus. If I take one minus, one more minus is left over. Okay, now, so did we get the required one? No, we didn't get it. Then again we are having the logic. The power, whatever is there to the top, it comes to the negative and also it comes to this power. This square is for both the minus and also to this bracket. I am sending the square. So what is the code? Minus to the power 2. Yes, it went to that. And the leftover cot theta minus cosecant theta whole square. What did I do? I sent the square to the minus and also this one. We know minus squared, it becomes plus. Minus squared, it's nothing but plus, simply plus. And what is left over? Cot theta minus cosecant theta whole square. So where did we start? We have started at that, therefore, right, secant theta minus 1 by secant theta plus 1. We got the answer as cot theta minus cosecant theta whole square. This is the concept. It's hence proved. This is how we are supposed to logically apply. So few tricks here applying right how to get the whole square. I have already taught you, and splitting the stuff and pushing it to the top and using the formulas what is required. In this channel, I have been placing both math and science videos.